Hello everyone, good morning. Welcome to our online class. So in today's class, we see discrete mathematics. So very important discrete mathematics. For JNTU students, it is there in second year, second semester for CSC and IT students. And Usmania University students, it is there in second year, first semester. That means third semester. Correct. And this paper is also called MFIT, Mathematical Foundation of Information Technology. And previously, this paper is called MFCS, Mathematical Foundation of Computer Science. Okay. So, few topics are different, but almost 80 to 90% syllabus is same for both the universities. Discrete mathematics, or we can say MFIT, or we can say MFCS, Mathematical Foundation of Computer Science. These all three papers are same syllabus. Okay. Now in these discrete mathematics, what units we have? First unit is what? Mathematical logic we have. First unit, mathematical logic. So all your truth tables which we learn in lower classes, like or and conditional, biconditional, those are all tables and truth tables we all are we use in this first unit. Then we have normal forms, quantifieds, and how to find the given condition is truth or not. Those all topics will cover in unit 1. Then coming to your unit 2, sets and relations we have, and some topics of functions also we have. Functions we have, and sets and relations we have, that will come under unit 2. Okay. So and unit 3 based on your elementary combinatorics. So that means binomial, permutation combinations, those all will come in unit 3. Okay. Now unit 4 is what? Based on generating function and recurrence relation. Very important. All units are important. So unit 4 is a little bit easy comparing to other units. Then fifth one is what? Graph theory we have. Fifth one we have graph theory. Okay. Now in today's class, which topic we discuss? We discuss today's topic, recurrence relation. So I will explain today unit 4, recurrence relations, right? So this will come under unit 4. Maybe for JNTU students, it will be, I think it is in unit 4 only, recurrence relations. It is, yes, it is there in recurrence relation unit 4. Okay. For Usmania University students also, it is there in university unit 4, right? So recurrence relation. Now, so what is the recurrence relation? First we have to see the definition of recurrence relation. Then we see how many types of recurrence relations are there. Then how to solve recurrence relation. And one more topic is what? We have to solve recurrence relation using generating function method. Very important topic, recurrence relation, and very simple topic also. Almost it is based on M1 linear differential equation, higher order differential equation, based on that only. So this recurrence relation also we get like similar questions we get. Okay. Let us start with the definition of recurrence relation. So what is definition here? A sequence AR may be defined by indicating a relation connecting its general term an with a an minus 1, an minus 2, so on, etc. Okay, etc. Like an minus 3, like that. What is telling here? A sequence AR may be defined by indicating a relation connecting its general term an with its lower term an minus 1, an minus 2, etc. Such relation is called recurrence relation for the sequence. And the process of calculating an is called solving the recurrence relation. The process of calculating an is called solving the recurrence relation. Very important topic. So in this we have how many types of recurrence relation? We have first order recurrence relation, then second order recurrence relation, then higher order recurrence relation. In that, homogeneous we have, and non-homogeneous recurrence relation also we have. Okay, so what is the first order recurrence relation? So in this, the first order recurrence relation, how it look like? See, first order recurrence relation. The form of the first order recurrence relation is what? An is equal to c into an minus 1 plus f of n, where n is greater than or equal to 1, where n is greater than or equal to 1. First order recurrence relation. What is the form of the first order recurrence relation, ma? An is equal c into an minus 1 plus f of n, for n is greater than or equal to 1. This is the first order recurrence relation. This one will come for 2 marks, ma. Then what will be its general solution? What will be its general solution? What we have to find here? We have to find here an. So general solution an is equal to c power n into a naught. General solution is what? C power n into a naught for n greater than or equal to 1, for n greater than or equal to 1. For example, if you want to solve one problem, see here example 1, solve. He will give you like this: solve an plus 1 is equal to 4an for n greater than or equal to 0. For n greater than or equal to 0, and he gave a naught is equal to 3 here. Suppose he asked the problem like this, it will come for short answer, ma. Solve an plus 1 is equal to 4 into an for n greater than or equal to 0, given a naught is equal to 3. So first what we have to do, we have to write this recurrence relation in this form. So how to write this form? This is for n greater than or equal to 1, and here he gave here n greater than or equal to 0. If I replace n by n minus 1, so what I get here? Solution given can be written as an is equal to 4 into an minus 1. Correct? If I replace n by n minus 1, I get an is equal to 4 an minus 1. So compare these two, ma. If I compare these two, so what I get here? If I compare these two, we get here in place of c we have 4. In place of c we have 4. So this implies now general solution is what? General solution an is equal c power n. What is c value? 4. So 4 power n into a naught. What is a naught value, ma? 3. So therefore, what is answer here? An is equal to, therefore answer is what? An is equal to 3 into 4 power n for n greater than or equal to 1. Why? Because we converted this in terms of an, no. So we converted this one in terms of an. So an is equal to 4 an minus 1. So general solution an is equal 3 into 4 power n for n greater than or equal to 1. So like this, you have to solve the first order recurrence relation. It's a very simple topic. So first order recurrence relation form is what? An is equal to c into an minus 1 plus f of n, for n is greater than or equal to 1. Now coming to second order recurrence relation. Second order recurrence relation will contain more than 2 roots and all. That we will see how to solve second order recurrence relation. So second order recurrence relation. Okay, so what is how the second order recurrence relation look like, ma? So the recurrence relation of the form, I can take cn an plus cn minus 1 an minus 1 cn minus 2 an minus 2 is equal to 0 for n greater than or equal to 2. For n greater than or equal to 2, cn is equal to cn an plus cn minus 1 an minus 1 plus cn minus 2 an minus 2 equal to 0 for n greater than or equal to 2. This is what? Second order recurrence relation form. Here right side we have 0. If right side is equal to 0, so what we call, these are homogeneous recurrence relations. Homogeneous, like in the mathematics 1 also, higher order differential equation when we are solving, when right side is equal to 0, we take homogeneous, correct? When right side we have a function, we take non-homogeneous. Similarly here also, if right side we have a 0, so it is called homogeneous recurrence relations, ma. Okay, then how to solve this second order recurrence relation? To solve this second order recurrence relation, we have to take, let an is equal to c into k power n. An is equal to c into k power n, where c is not equal to 0 and k also not equal to 0, ma. Okay, then we have to substitute here. Then if I simplify, so I get this recurrence relation in the form cn k power n plus Cn minus 1 into C into k power n minus 1 plus Cn minus 2 C into k power n minus 2 is equal to 0, right? So here C will come, otherwise you can take the C. Now C, take out C common, and n is greater than or equal to 2. So if I start here, so what I get here, Cn k square, so Cn minus 1 k and Cn minus 2, correct, is equal k power 0. K power 0 is equal to 0. So C we take it out that side and send to that side ma. So Cn k square plus Cn minus 1 k plus Cn minus 2 k power 0 equal to 0 ma. Is nothing but k power 0 is what we can take it as k power 1. So this is converted into quadratic equation, right? So now you will find the roots. So how many roots we get here? We get 2 roots ma, correct? We get 2 roots. Now what are the cases here? K1 and K2 we get 2 roots, right? Now based on this K1 and K2 we have its auxiliary equation. Auxiliary equation we have, correct? Auxiliary equation we have, like in M1 also we find 2 roots no for differential equation. So like that here also based on the K value we get 2 roots. So first one, if I get K1 and K2 are 2 different roots, if K1 and K2 are real and distinct, then what I get here, auxiliary equation can be defined as an power h is equal to a into K1 power n b into K2 power n, a into K1 power n plus b into K2 power n ma. Suppose if I get a 2 roots are same sorry, K1 and K2 are same, then an power h is equal to a plus bn into k power n ma. K1 and K2 are same, that means K1 and K2 is equal to k if I take. Then if I get complex roots ma, K1 and K2 are complex roots, that means complex roots. So if it is in the form of p plus or minus iq, so K1 K2 in the form of p plus or minus iq, then here an power h is equal to what I get here, r power n into a cos n theta plus b into sin n theta, a cos n theta plus b into sin n theta. So what is a and what is theta and r here? Here r is equal to square root of p square plus q square, r is equal to square root of p square plus q square, and theta is equal to tan inverse of q by p. Theta is equal tan inverse of q by p. Okay, so this is a second order recurrence relation in the form Cn an following Cn minus 1 an minus 1 Cn minus 2 an minus 2. So how to solve? An is equal to c k power n, so it will convert into k square k power 0. So we get 2 roots over here, so 2 roots can be these 3 ma. 1, 2 roots are different, 1, 2 second one 2 roots are same, third one if I get 2 roots are complex, like alpha plus or minus I beta we used to do. So here I took p plus or minus iq form, right? So this is the second order recurrence relation, very important ma. Okay, when we solve one problem, then you will clearly understand what is the how to solve second order recurrence relation. Okay, let us see one problem, then you will understand. Okay, see the first problem ma. So very important problem. This problem came in one second. Okay, this problem came in last year problem. So what is the problem here? Solve an plus an minus 1 minus 6an minus 2 is equal to 0. For n is greater than or equal to 2, and the conditions he gave here, a0 is equal to minus 1 and a1 is equal to 8. Correct? So how to solve? First of all, identify which type of recurrence relation it is. We have an minus 1, an minus 2. So nth term, n minus 1, n minus 2. So it's a second order recurrence relation and homogeneous, right side we don't have anything, right? So now how to solve this second order recurrence relation? So first one, auxiliary equation we have to write, right? So given directly you can write auxiliary equation. In place of an we have to take k square, and an minus 1 can be taken as k, and an minus 2 can be taken as k power 0. That means k power 0 is 1, it can be written as 6. So k square plus k minus 6. So what are the roots 3 2s are 6, k plus 3 into k minus 2. K plus 3 into k minus 2. So I get here k1 is equal to minus 3 and k2 is equal to 2. So otherwise you can take k1 is 2, k2 is minus 3, your wish. So I got two different roots. So what is the auxiliary equation if I get two different roots? An power h is equal to a into k1 power n plus b into k2 power n. So therefore an power h auxiliary not auxiliary equation auxiliary solution, correct? Or you can write complementary function and complementary solution we can write. So an power h can be taken as a into k1 power n. What is our k1 minus 3 power n. Achha, let us write the formula. k1 power n plus b into k2 power n. So a into k1 is what? Minus 3 power n. b into k2 is what? 2 power n. Correct? So it's a solution, right? Now auxiliary equation, you can say complementary solution. Now what he gave here? He gave two conditions over here, correct? He gave two conditions over here So why he gave these two conditions here? To find the constants a and b. To find the constants a and b, he gave two solutions over here. So therefore, so this can be written as general solution an is equal, here there is no right hand side, we can take directly an is equal a into minus 3 power n, b into 2 power n, mark it as 1, correct? Now what are the conditions he gave here? Given a naught is equal to minus 1, a1 is equal to 8 two conditions he gave here. So that means if n is equal to 0, if I substitute n is equal to 0 here, so it becomes a naught. What is a naught value? Minus 1. So let n is equal to 0 in 1, in equation 1. So what we get a naught, in place of n you have to write 0. A naught is equal to a into minus 3 power 0 plus b into 2 power 0. So a naught is how much? Minus 1, and anything power 0 is 1, anything power 0 is 1, a plus b is equal to 1, you get another equation, right? Next, let n is equal to 1 in 1. So what I get here, if I substitute, this is equation 1, no? If I substitute n is equal to 1, a1 is equal to a into minus 3 power 1, b into 2 power 1. a1 is how much 8. 8 is equal to minus 3a plus 2b. This is our second equation. That means third one, nothing but third. So now solve 1 and 2. So if I solve this 1 and 2, 2 and 3, solving 2 and 3, solve 2 and 3, that means multiply this by 2 or 3 and add it, subtract it, we get the value of a and b. A is equal to minus 2 I got, b is equal to 1 I got. Using calculator, I calculated a is equal to minus 2 and b is equal to 1 I got. A is equal to minus 2 and b is equal to 1 I got. So therefore, this a and b values we have to substitute in equation 1. So therefore, general solution an is equal to, a is what? Minus 2 into minus 3 power n, b is what? 1 into 2 power n. Now whatever the value of n, you will find it's a term, you find its nth term, right? So if I take n is equal to 100, you get the value. If I take n is equal to 1000, you get the value of that general term. Understand? So like this, you have to find this second order recurrence relation using, you have to find a second order recurrence relation. So understand the type of the second relation, how it look like. It look like nth term n minus 1, n minus 2, right? So can be replaced by n is k square and n minus 1 is k and n minus 2 is what? K power 0, right? Then you will get the roots. So it is what? Auxiliary equation, then you get the roots, then complementary function. So an power h is what? This one. Otherwise you can, here there is no right side term, you can directly take it as an. So after getting an, use the given conditions, substitute that n is equal to 0, you get a naught, substitute n is equal to 1, you get a1, you get the equation in terms of constants ab. Solve these two equations, you get the values of a and b and substitute here. So very simple problem. It's completely based on our M1. I think it is there in a few students in M2 also. In M2, higher order differential equation. Okay, same method. So solve this problem. In the next video, we'll solve more problems on this recurrence relation. Thank you.